Q8296. On an aircraft turbine engine operating at a constant power, the application of engine anti-icing will result in A. Noticeable shift in EPR. B. A false reading in EPR. C. An increase in EPR. The correct answer is A. When engine anti-icing is applied on an aircraft turbine engine operating at a constant power, it can cause a noticeable shift in the engine pressure ratio, EPR, reading. Engine anti-icing systems typically divert a portion of the engine bleed air to heat and protect the engine from ice buildup. This diversion of bleed air affects the engine's overall performance and can lead to changes in EPR. EPR is a measure of engine thrust and is influenced by factors such as airflow, temperature, and pressure. Q8297. Engine pressure ratio is the total pressure ratio between the A. At the end of the compressor and at the end of the turbine. B. Front of the compressor and the rear of the turbine. C. Front of the engine inlet and the aft end of the compressor. The correct answer is B. Engine pressure ratio, EPR, is defined as the total pressure ratio between the front of the compressor and the rear of the turbine in a gas turbine engine. It represents the ratio of the total pressure at the exit of the compressor, front of the engine, to the total pressure at the exhaust of the turbine, rear of the engine. EPR is an important parameter used to measure the performance and efficiency of a gas turbine engine. Q8298. What would be the cause if a gas turbine engine has high exhaust gas temperature, high fuel flow, and low RPM at all engine power settings? A. Fuel control out of adjustment. B. Loose or corroded thermocouple probes for the EGT indicator. C. Turbine damage or loss of turbine efficiency. The correct answer is C. If a gas turbine engine exhibits high exhaust gas temperature, EGT, high fuel flow, and low RPM at all engine power settings, it indicates a potential issue with the turbine section of the engine. This could be due to turbine damage or a loss of turbine efficiency. The high EGT and high fuel flow suggest that the combustion process is not being effectively converted into mechanical energy, resulting in excessive heat and fuel consumption. The low RPM indicates a reduction in the rotational speed of the turbine, which can be caused by damaged or inefficient turbine blades or other components. In such cases, it is important to inspect and address the turbine section for potential damage or inefficiency to restore proper engine performance. Q8299. What is the primary purpose of the tachometer on an axial compressor turbine engine? A. Monitor engine RPM during cruise conditions. B. It is the most accurate instrument for establishing thrust settings under all conditions. C. Monitor engine RPM during starting and to indicate overspeed conditions. The correct answer is C. The primary purpose of the tachometer on an axial compressor turbine engine is to monitor the engine's RPM, rotations per minute, during starting and to indicate overspeed conditions. During engine starting, the tachometer provides feedback on the rotational speed of the engine to ensure it is within the specified range for safe and proper operation. It helps the pilot or technician monitor and control the engine speed during the starting process. Additionally, the tachometer serves as a safeguard against overspeed conditions. If the engine RPM exceeds the maximum allowable limit, the tachometer will indicate this overspeed condition, alerting the pilot or operator to take appropriate action to prevent potential damage to the engine. Monitoring engine RPM during cruise conditions or establishing thrust settings is not the primary purpose of the tachometer on an axial compressor turbine engine. Q8300. The engine pressure ratio, EPA, indicator is a direct indication of A. Engine thrust being produced. B. Pressure ratio between the front and aft end of the compressor. C. Ratio of engine RPM to compressor pressure. The correct answer is A. The engine pressure ratio, EPR, indicator is a direct indication of the engine thrust being produced. The EPR is a ratio of the exhaust gas pressure to the engine inlet air pressure, and it provides a measurement of the engine's output thrust. By monitoring the EPR, pilots and operators can assess the level of thrust being generated by the engine.